Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
So the bulk of this video is going to be teaching you how to do a specific technique in the lab, and it's called a titration. Now, before we talk about a titration, there's some really important definitions that you need to understand and know so that we can talk about this. The first one is called a standard solution. And a standard solution is a solution of a known, or like a super accurate concentration. So if I make up a solution, and we're talking about acid-base titrations, let's say I have a solution of sodium hydroxide. And by the way, this bracket, I don't know if you've talked about this, but the bracket means the concentration of, and it's going to be in some number molarity. And let's say this is a 3.21 molar solution. So I know it to be super accurately to be a 3.21 molar solution. And we can also change this and not just use it in a sort of noun sense, but we can say a standardized solution, SOLN is the abbreviation for solution, is one where we have found its concentration super accurately. A standardized solution, we know its concentration accurately. The second thing we want to talk about in a titration is what we call an endpoint. Now the endpoint is where the acid, so you're putting an acid with a base, where you've got the number of moles of acid is equal to the number of moles of base. All right, so we have a reaction. Let's go over here. So let's do this. HCl plus NaOH makes water and salt, right? But if I end up with the same number of moles, let's say, 2.2 moles of this and 2.2 moles of this, when I get to that exact point, that's called the endpoint. Which leads us to, how do you know you've reached the endpoint? So essentially what we're going to do, and you're going to see this in just a second, we're going to have a big long tube with the point and a little valve at the bottom. We're going to have a flask down here, and usually we'll put the base down, put the acid down here, and we'll put the base up here. And then we're going to drip it into there until it reaches the endpoint. But how do you know you've reached the endpoint? It leads us to our fourth and final thing. We need to have something called an indicator. Now an acid-base indicator is something that changes color at a specific endpoint, or specific pH, pardon me. And so what you're going to do is that as you add this, you're going to have the base down here, is once it reaches a particular color, and the indicator that we're going to use mostly is something called phenolphthalein. That's a fancy word. Phenolphthalein is how you spell it. And when it turns pink, just the very moment, that's when you've reached your endpoint. And then, for example, if you know the concentration of the HCl, right, it's standardized, you can then calculate what the concentration of the NaOH, and then you've standardized your NaOH. We'll be doing a big lab, like 3 days, to help you figure out how to do all this stuff. All right, so that's kind of basics for a titration. How do you actually do a titration? Let's cut to that. Chemistry is awesome. Today we're going to learn how to use a cool technique called a titration. A titration involves the use of a long tube thing called a burette, super accurate way to measure volume. We're going to put a base at the top, we're going to put an acid in the bottom, and we're going to add an indicator until it turns color. First off, I'm going to pour the base into the tip of the burette. Now I want to be careful that I don't allow it to overflow. I want it to kind of go up. You may not be able to see all the liquid going. Now what I'm going to do is I'm going to take what I call a waste beaker, and I'm going to put this in the bottom of the burette. So now what I want to do is I want to drip it down. I'll show the dripping process. I want to just drop that down till it gets to the 0 mark. I don't know if you can see this, but I want to get to exactly the 0 mark where the meniscus is right on the 0. Wait for it. Trying to get real tall so I can see it perfect. Now I can see it's right at the 0 mark. So now I have what we call a full burette. Next up, I'm going to add the acid into the flask, the exact amount. Next, what I need to do is I need to add a couple of drops of the indicator. The acid-base indicator happens to be phenolphthalein. And now what I want to do is I want to add the base to the acid. The acid is down here, and there's a few drops of phenolphthalein. And I want to get it till it reaches the point where it just turns it pink. Now you might notice that it's starting to turn it pink, but if I shake it around, the pink color goes away. What I'm looking for is for the pink to just be the very faintest hint of pink. I want to add enough base so that the pink actually stays just a little bit. And now what I can do is, as I'm getting close, also one thing to note here, I've got this white thing underneath. The white thing is just so I can see color contrast. And I want to get to the point where just one drop, and I think I just overshot the end point, one drop turns it from clear to pink. And now what we need to do is we need to get it to read the actual burette. And so if I look at this real closely, it looks to me like we're at about 33.1 milliliters. And that's how we do a titration. Now, one last thing. How do you clean this thing up? Now, sodium hydroxide can etch glass. So I've got sodium hydroxide, particularly if you have sodium hydroxide inside the burette. What you need to do is possibly you're going to save it. So you're going to want to drain the whole thing, all right? Drain the whole thing. And then you need to rinse out the burette twice with water. You need to make sure that there isn't any residual sodium hydroxide in the beaker. So I'm letting this drain, and then I'm going to put water in it, drain it, water in it, drain it, then it's ready to be put away. Now that may seem complex, and probably is to some degree, but titrations are one of the heart and souls and most important types of experiments that chemists do. So now, of course, in class, what we're going to do? We're going to do a cool titration until it turns pink. It'll be awesome. We'll see you in class.